Hey everybody. So we're going to spend another day talking about this interesting computer science problem that is trying to teach a computer to recognize colors here for our app development class. The idea is that a computer, given the red, green, and blue values for each of those three channels, we want to be able to teach the computer what we as humans think each of those colors are. And so we're going to be using a machine learning algorithm called a regression to actually try to do this. Last time we talked about the collect portion of the process of building a data set for a machine learning algorithm, and we're going to talk a little bit about training it today. But that's also going to reinforce some of what we've discussed previously about collecting and training data and how we can be very deliberate about putting that data set together and how to do a good job of it. The reason I bring this up is that when we are training a machine learning algorithm, usually we want a lot of data. We want a good amount of data because what machine learning algorithms do is they look at all that data and try to find the patterns, the big picture patterns in all of that data. And when you only have a couple pieces of data to give it, it doesn't do as well as when it has a lot to look at. That said, it helps when that data is carefully curated to match exactly what it is you're looking for. Sometimes if you're a little bit careless about that data that you put into your algorithm, you're not going to get as good of an output. And so we'll talk a little bit about that. Typically what you do is you make your set of data. Usually you decide to size the amount of data in your training set to be about 80%, your testing data to be about 20%. So let's actually take a look at the process of getting the data from what you collected to the classifier. So we're going to zoom out and go to our spreadsheet. Now, what I've done actually is I have taken a few of you who have submitted some data to me, and I've actually put it all together. You don't usually just do that. Usually you want to be a little more deliberate about it because this doesn't necessarily work. But I want to just show you some of the things that you can do with that data to get an understanding of how well it's going to work. The first thing that I want to do is that I have these categories of red, green, blue, and other that I've given the classifier. And what I want to do is actually see how many of each category are in the training set, are in the training data, so that I can tell whether there's a balance between those categories. So let's do that. Okay, so I've used some spreadsheet commands to kind of count up how many of each kind that I have. And so I might be a little concerned because if you look at the way this data is distributed in my data set, I have 50 greens and 50 blues, which is pretty good because that's balanced. I have more others, and I also have fewer reds. It's not clear whether that's really going to have an effect on my data, but it's just something to be aware of. Usually you try to have some balance between the different classifiers so you can really give your algorithm a good understanding of what each of them are. Let's do the same process but with the testing data just to see what the relationship is. So I'm going to do that by copying this over to the other spreadsheet into cell F4. Okay, so in the testing data, I have red and green about equal. Blue is pretty close. It's only 4 more than the others. And then the other category is 28. So we have a little bit of an imbalance between our 4 categories, and that might be okay. It's just something we want to be aware of. Because remember, when you're testing your classifier and evaluating it, you want to see how well it does at determining all your different categories. And if it's biased towards one or the other, you might get an overall less accurate picture of how well it's doing. Okay, I'm going to delete these parts of the spreadsheet now because we're going to export the data so we can import it into the CreateML trainer. And this is really easy to do. I'm going to go to the training spreadsheet. I'm going to go to File, and I'm going to go to Download. and we want to select comma separated values. And so what that'll do is it'll download that spreadsheet to the downloads directory. It'll give you a CSV file which has all of those values separated by commas. We can actually open it up and take a look at what the raw file looks like. So if I just open this up there, it opens up like a spreadsheet, but if I open it with maybe a text editor like this, this is what it looks like. So it's a whole bunch of values separated by commas. And I've left the labels in there because the trainer is actually going to use that. It's going to make it a little bit easier. So you want to make sure you do that both for your training and your testing data. So I'll go to the testing spreadsheet and then hit download CSV. And what's really nice about this is it actually names them differently. It names them using the spreadsheet. And that's kind of why I recommended you name these two tabs as training or testing, because it makes that whole process much easier. All right, let's train the classifier. All right, so there are two ways that you can go about actually doing the training. If you go up to Xcode and you go to Developer Tool and you see Create ML, that is the easiest way. I'll show you how that works real quick. We'll go to Create ML. We'll create a new document. This one is going to be a tabular classifier because it's coming from a table and we're classifying the values from the table as red, green, blue, or other. So we're going to hit next. We'll call this my color classifier. Hit next, we'll save it, and now you put in the training data. So I'm going to choose the file that was downloaded, first my training data, and because of the way I've named it, it's going to make some of the next step a lot easier. So what you do is you select the target, which is what we want the classifier to identify, and that's color label. And we're going to select red value, green value, and blue value as the features that we want to use to try to predict the color label. So we do that, it's happy. We go to testing data, we select our testing CSV file, and 195 items, 83, we're good to go. And now we're going to make the algorithm automatic, which means CreateML is going to figure out which method, because there are a lot of different ways that you could actually classify a table of data. CreateML is going to find the best one and present it to you. So we hit train, and unlike the image classifier, this is actually really fast. So 2 seconds, and it trains and also gets all the testing done. And so you can see it's not bad. It's not great the way I've done it. So other 68%. For precision there. Red is 61%, so we probably could do a better job here. It might be useful to see what it's getting wrong, or what the classifier is getting wrong, what it's getting right. And the easiest way to actually do this might be taking that model and putting it in our file, which we're going to cover. So we can take the model just like we did before, and we can actually drag this model wherever we want. So this is the trained classifier. If you go up to this menu and you don't see Create ML, what you need to actually do is open a different file. I've created a Swift Playground that you can open, and the Swift Playground has the functionality built into it for you to be able to do the training. So you can download this file and open it up. It's just a zip file, and it looks like this. And you have to change a couple things in order to get this to work. So one thing, you need to take your testing and training CSV files and drag them into resources. The next thing you need to do is, this is where the training file is loaded. You have to go into this right here and replace it with the name of your training CSV. So make sure you have the training selected, and then you go back here between the quotes and get the file name. You don't want to have the .csv in there because it knows that it's a CSV file from this little extra thing. So there's that. The next thing is you want to go down here to the testing CSV file, and change this name. Instead of just testing.csv, you go to the testing file, and you want to get the name directly out of the file in the sidebar. So what color is this? Testing, again, no .csv. And then once you've done that, you can run the playground. And what it'll do is it'll actually go through those files, and it will do the training. And it's actually kind of cool that it shows you all of the different things that it's trying, because it's trying a couple different methods to come up with the optimal way. And so you can go through the different kinds if you want. But we'll scroll down to the end, where it's actually going to give you some of the testing data, and these are the same numbers that you saw in the Create ML tool. It also gives something else which is kind of useful, which the other doesn't, I don't think, and that's something called a confusion matrix. And so the idea behind this is it tells you down the middle, it tells you which ones were done correctly. So this means that there were 19 blues that were classified as blue. It also means that there was one true blue that was classified as green and one true blue that was classified as other. So this data can be really useful for understanding why the classifier is or is not working. So check it out. And so what this does is this saves the model, and it tells you where it is, so it gives you a path. So this is in your home directory in Finder. So if you want to get to your home directory, you can go to a Finder window, you can do Go, you can do Home, and then there's this directory called, Documents. If you go to Documents now, and you go to Shared Playground Data, that's where it's going to be. So right in there is our color classifier model. So in both of these cases, we've created a classifier model, and now what we want to do is try to use it. So the next step is going to be loading this model into our Xcode classifier program and seeing how well it does. Nice job, everybody.